Hello everyone, my name is Nirmala Gandhi and I am working as an assistant professor in the department of CSE in KSR College of Engineering. Today we are going to discuss about the topic CPU scheduling algorithm. CPU scheduling is the process of deciding which process is going to execute in the CPU at a particular instant of time. Basically, the scheduling is categorized into two types, that is preemptive scheduling and non-preemptive scheduling. In preemptive scheduling, a CPU can release a particular process in the middle of the execution. In non-preemptive scheduling, once a process is assigned into the CPU, it does not release in between the execution. It should release that process once it completes the execution. And some of the terminologies used in scheduling criteria are that is the first one is arrival time. That is time in which a process arrives in the ready queue. Next one is completion time. That is the time at which the process completes its execution. And next one is burst time. That is the time taken for the entire execution of the process. Next one is turnaround time. This turnaround time is the summation of complete execution time of that process and the waiting time of that process which is in the ready queue. In order to calculate the turnaround time, this is the formula, that is waiting time plus burst time. That's a waiting time is calculated by starting time of that execution and the arrival time of that execution. That is the time at which the process is going to start its execution, and this arrival time is the time at which does enter into the queue. And next one is response time. That is the time duration exists between the submission of the process and the first response which is going to receive. These are the terminologies used in this scheduling criteria. And for an optimized algorithm, these are all the key points which is going to evaluate. That is the first one is that is a maximum CPU utilization, and next one is a maximum throughput and minimum turnaround time, and it should be minimum waiting time and should be minimum response time. Based on this criteria, an algorithm is said to be an optimized one. And this CPU scheduling algorithm is of four types. First one is first come, first serve, and second one is shortest job first scheduling. Third one is priority scheduling, and last one is round robin scheduling. Let's see one after another. The first one is first come, first serve scheduling. This is the simplest form of CPU scheduling. That is, whenever a process enters into the CPU, that is to be executed, and that is to be allotted first, and that is executed first based on first come, first serve. Which one executes first in the CPU, that is going to be executed first. It is easiest one, and we can easily implement it. And it is a non-preemptive scheduling algorithm. Let's see an example for this. Here the process P1, P2 and P3 are three processes which are going to execute, and for each and every process execution there is a separate burst time is given. That is, burst time is the time taken to complete that process. For process P1, it takes 24 milliseconds. For process P2, it takes 3 milliseconds, and for process P3, it takes 3 milliseconds. In order to show the execution, that is, order of the execution is given on the Gantt chart. This Gantt chart shows in which order the process is going to execute. The process arrives in the order of P1, P2, P3. So it starts the execution from P1, next execution is P2 and P3. Initially for process P1 there is no waiting time, it directly enter into the execution. So for process P1 the waiting time is 0. The process P1 takes 24 milliseconds for execution. After that, the process P2 starts. So the process has to wait for 24 milliseconds for execution. Then process P2 takes 3 milliseconds for execution. So totally 27 milliseconds are taken for process P3 to wait. So total execution time is 30 milliseconds. We are going to calculate the waiting time, average waiting time, turnaround time, and uh, average turnaround time. For calculating the waiting time, we are going to use this formula, that is the starting time minus arrival time. Starting time is the time in which the process is going to starts its execution, and arrival time is the time at which the process is arrives in the ready queue. And for turnaround time calculation, it is the summation of waiting time and burst time, that is the total execution time of the process. For process P1, the starting time is 0 and its arrival time is 0. So the waiting time for process P1 is 0. For process P2, the process P2 waits for 24 milliseconds till the completion of process P1. So its waiting time is 24 and its arrival time is 0. So 24 minus 0 is 24. And for process P3, it waits for around 27 milliseconds, that is 24 milliseconds for process P1 execution and 3 milliseconds for process P2 execution. So the process P3 waits around 27 milliseconds and its arrival time is 0. So we get 27. So the average waiting time for this workers, that is 0 plus 24 plus 27 and whole divided by 3, will get 17 milliseconds as average waiting time. Next, turnaround time calculation for this process is, we say turnaround time is the summation of waiting time plus burst time. So the process P1 waits